Hi guys, in this video we're just going to work through another example dealing with general rational functions and how to graph them. Our first step is to factor the numerator and the denominator separately. So before we get going, we're just going to simply rewrite this as, instead of x squared plus 3x minus 4 on the top, we know how to factor that. That's x plus 4, x minus 1. That's going to be an important concept and a key part of going further with these, okay? So now this is going to be a heck of a lot easier to work with, okay? So the reason why will become apparent in a little bit. First step after this, after I've factored, going and looking at the top of your notes, is I need to set the denominator equal to 0 and solve for x. So I'm going to take the x minus 2, I'm going to set it equal to 0. That means x equals 2 is the location of my asymptote, right? So there's my vertical asymptote, is at x equals 2. I'm going to come up here on my graph, and I'm just going to put a dotted line at x equals 2. And I know that's going to be the separating point. I'm going to shoot upward or downward there. As far as where I'm going to level off at, I need to compare the degrees, the numerator and denominator. And here I see that I have x squared over x. So I have a bigger x on bottom than on top, than on the bottom, a higher degree, second degree, first degree. That means I have no horizontal asymptote. Now here's what I want to point out on this one. Okay, and the reason I brought this example up, I really debated about whether I wanted to or not because it brings up a thing called a slant asymptote, and it's something that I really don't want to deal with. We don't have the time to deal with it, but if you go on to pre-calc or college algebra, you are going to see it. And it happens when the degree of the denominator is exactly one less than the top. So x squared, x to the first. If that was x to the fourth and x cubed, you get the same thing. X to the 17th power and x to the 16th power on bottom, you get the same thing. But really, what happens is this, okay? I'm going to go through, I'm going to graph this, I'm going to show you the picture, and we'll just use this as the starting point for the rest of our problem. So I have x squared plus 3x minus 4 on top, notice my parentheses, divided by, notice the parentheses, x minus 2. Forget the parentheses and nothing's going to work, okay? It's not going to look like this at all. When I go to graph it, there's my x equals 2 line, right? This line is actually off of it. I guess I just need to zoom out a little bit. Let's go to my window. I'm going to make it negative 20 to 20 instead. So we just zoomed out a little bit. But you see what's going on, right? And it almost looks as if what's going on is we have an asymptote that's kind of slanted. It approaches a line here, but it looks like a y equals x plus 5 or something. I mean, I don't know, right? Okay, so there's actually a line there that it approaches, but we're not going to get into that. So I'm going to show you this in the example. I wanted you to see what it looks like and be able to graph it and trust your graphing calculator. Okay, we'll get some weird shaped graphs here, but I want you to not be scared of it. I want you to be able to go on. Okay, so we don't have a horizontal asymptote. Okay, but we do know that we can set the numerator equal to 0 and we can solve for x. And so if I have x plus 4 times x minus 1, there's my numerator, and I set it equal to 0, that means that x is equal to negative 4 from this one, or positive 1 from this one, right? And so I know that there are two locations that I cross the x-axis, negative 4 and positive 1. So on my graph, I'm just going to put a dot at negative 4, and I'll put a dot at positive 1, and I know that those are the only two ways that it crosses. Now, the great thing is because I already have this in the calculator, I can just go to the table, and I can use this to get all the rest of my values. And I would suggest just picking out enough that you can graph the curve. Like 0, 2 is going to be a good one right there. 1.5 gives me a negative 5.5, so let's do that one. It'd be like somewhere around here, right? Negative 5 is 2.1, negative 1 and positive 2, okay? And it looks like it starts to do something like this. And remember, there's the graph. So it should look like this. I'm just using the table to get some accurate points. Okay, it's going to do something like this. So notice it doesn't level off. And over on the other side, if I go over to the right of 2, I just want you to notice that, hey, look how high those values are. So you can't even graph the next part of this. It's too high off the graph. Okay, so that's kind of what we're doing here. Okay, just getting an idea, using our graphing calculator, matching pictures, but then also knowing some basic steps. So if I ask you where the intercept is, you understand that I'm asking to find where it crosses the axis.